So in this problem, we've been given the angle theta. The angle theta is described with the ratio -3/7 in quadrant 3. So we don't know the size of this circle, but we know the positioning is going to be based on the cosine position. And we're told that it's in quadrant 3, so we don't have to worry about whether it's above the x-axis or below the x-axis. In this case, quadrant 3 is down here, so there's my quadrant 3. So Q3 is down here. And the cosine goes with the x. So this is going to be the x in the radius. I'm just going to arbitrarily use that value as my x coordinate and that as my radius. So -3, +7 is going to look something like this. Okay, so it's going to locate that position in quadrant 3. So I want to find the sine and tan ratios for this angle. Okay, so that's my angle theta. And so I need the third side, so I'm going to use Pythagoras. So I'm going to use 7 squared minus -3 squared. So that's going to give me root 40. Now, because position is all important, I need to make sure that I recognize that that's going down. So it's going to be negative root 40. So I'm just going to highlight that because that's a very important piece, that negative. So once I have this triangle, I can establish my sine and tan ratio. So sine theta is going to be the y positioning over the radius. The tan ratio is my slope, so it's going to go negative root 40 over -3. That's a positive slope, so root 40 over 3. So unit circles, the nice thing about unit circles is the coordinate on a unit circle is going to be reflected in the cos and sine ratios. So when I have my x position on a unit circle, and this is only for unit circle, the x position, actually I'm going to choose a different color here, the x position, in this case m, that relates to the cosine of the angle position. And when I talk about the y position, really that is the sine ratio. So those are equivalent in a unit circle, okay? And again, that's for a unit circle. So we have here the point MN is the intersection point of terminal arm of angle theta. So I'm just going to sketch this diagram here. I'm going to assume that's a unit circle. And we don't know where it is, as M and N are generalized. So I'm just going to arbitrarily draw it in quadrant 1. Okay, so the M position is my cosine, so that length here is my cosine. That's M, and the N position is a vertical position, so that's N. And determine the value of sine theta and secant theta. Well, sine theta, well, N is just sine theta, because a vertical position on a unit circle, again, remember this is specifically a radius 1 circle, the vertical position represents sine. We also know that the horizontal position is cosine, so cosine theta must be equal to m. But I want secant theta. I want 1 over cosine theta. That's same as secant theta. So that must be 1 over m. So 1 over m then reflects the value of that secant theta. In this problem here, we have a lighthouse. Okay, it's centered at 0, 0. And it has a light range of 25 kilometers. So the radius at which this can shine out is going to be 25 kilometers. So a ship passes a lighthouse 1 kilometers away, and moves in a straight line north. Okay, so it's moving like this. I'll choose a different color. So this is a path of that is going to be the path of my ship. Okay, and that distance is going to be 1 kilometer along there. Okay, so it's passing there and it's moving on a straight line north. Okay, so assuming the lighthouse is at the closest point at 1 kilometer, so the closest point is going to be there, we want to know how far north can it travel before it cannot see the light. So it's going to be basically traveling to that point right there. So there's my 25-kilometer range, and we want to know how far north we can travel. So we want to find this vertical distance here. So the new angle, so how far can it travel before it cannot see the light? So we're going to use Pythagoras, so it's going to be 25 squared minus 1 squared. So that's going to be work out to square root of 624 in the positive direction. So for part A, it can travel root 625 kilometers north. And then what's the new angle from the position it was closest to the white lighthouse? So this angle in here, this different color here, theta, that's second part of the problem. If I want to find that angle theta, I just need to undo one of those ratios. So I'm just going to choose the cosine ratios. So I'm going to say cosine of theta is equal to the horizontal position over the radius. I need to inverse cos or arc cos this to work out the angular value, the angular position. So the angle works out to be, I'm going to do second cos, 1 divided by, so I end up with an angle of 1.54. So it's very close to 90 degrees, which is 1.57. So I get 1.54 radians is the angular position that locates that point.